Hello, everyone. Welcome to the sixth and final hour, and also sixth and final day, I guess, and sixth and final week of the Web Simulation Development Fundamentals using Forio Simulate webinar series that we've been running. This is Michael Bean again. I know for the last 3 weeks you've been talking with, or at least listening to, Billy Schoenberg, so I'm back again for the final session here, kind of wrapping things up and really bringing this all back together again in terms of, what are all the things that we've learned over the last 5 weeks, and how do they all tie together in terms of producing a useful sim. So, as I'm sure you remember, over the first 2 weeks we covered model building, and we went, I think, fairly rapidly through a lot of material there in terms of learning about arrays, learning about how to use state variables like stocks and things like that. And then Billy, over the last 3 weeks, really has been covering interface design, first with the basic user interface design and setting up, for example, faculty or facilitator pages, and then getting into intermediate interface design issues, doing fancier things with the UI. And then last week, of course, doing the multiplayer games. What I wanted to do today as sort of the final piece was cover game design and project management. When Billy and I were discussing this workshop a few months ago, or I guess 2 months ago or so, one of our big debates was where to put this piece of it. We were initially thinking we should put it at the beginning. We thought, well, this is sort of the most important thing that people need to learn is this game design and project management, so we thought we'd put it at the very beginning of the workshop. And we thought, well, a lot of people are really going to want to jump in and try out to learn more about the techniques and technology and things like that first. And so that we want to do that. So we decided in the end to put it at the end. And I just got a note from Matt saying that, can people hear me okay? Am I loud enough? Okay, Matt's saying it's okay. All right, thank you, everyone. So anyway, so here's this piece of it. And like I said, I think it's a really important piece. And I do think now that I've reflected back on it as I've prepped for today's workshop, I thought, it does really work well at the end here, so I'm pleased that that's where we ended up putting it. So what we're going to talk today about is the difference between models and simulations. We probably have some hints about where that's going from our earlier work so far. But also, I think three really key things is how to make simulations easily understandable, how to make sims convenient to access, how to make them enjoyable, and how to make them enjoyable to use. Then we're going to talk a little bit about project management. And then to wrap things up, I'm going to talk about the most important thing you can do to create a high-quality simulation. So that'll be one of the last things that I cover during our talk today. And I think the way to start this off really is to talk about why is it that we're doing all of this? What is the point of building these simulations online in the first place? And really, I think the fundamental reason for it is that most simulations and even most games historically have been trapped on the desktop. So that if you think about, especially in the context of a simulation, there's some fantastic desktop simulation tools out there in a variety of on a variety of sort of methodologies on system dynamics and discrete event simulation, Monte Carlo, agent-based simulations, and so forth. But for the most part, they're all running on the desktop. And if you wanted to share one of those simulations with one of your colleagues, the problem is you'd have to ask them to install specialized software, which might take 15 minutes or so or something, and then load this application and kind of work through an unfamiliar interface in order to use it. Even if it's something like Excel, you have all this extra stuff at the top. You have to kind of figure out how to navigate it. And maybe you can do some things to improve it, but it's still challenging. And what that means is that unless the people trust you, unless they believe, I'm going to learn a lot from you because I've worked with you in the past, they're probably not going to be willing to do all of that. And so obviously we believe, and possibly you also believe, since you're sat through 5 weeks of this so far, that there's a wider variety of people, that the big value added from this is sharing it. So what this is all about is getting simulations online so that more than people that you know and that trust you because they know you personally can benefit from work that you've done or work that colleagues have done. And but in order to do that, you can't just throw it online. So it's not like how I made my first million on the internet. Just get it out on the internet and suddenly you have millions of users or something like that. In fact, what you need is some kind of interaction interaction occurring between the contributor, meaning the simulation author, and the audience. And what we've learned through hard experience over the last several years here is what are those factors? What are the special factors that result in designing a high-quality simulation that's going to get lots of visitors? And that's really what I want to talk about in this sort of first two-thirds or so of our time together today. And just to give you an example of that, you know, many of you may have heard of something called the power curve. The power curve is this concept that applies to things on the internet largely, but it can apply to things outside of the internet too, is that, you know, often people talk about the way that things are distributed within, say, a population of some sort is through a normal distribution, right? So, but online, there's lots of things that don't follow a normal distribution. Instead, they follow this power curve distribution. And one example of this that I pulled off a few months ago, actually, was Twitter users. So what you can see on this diagram here is you have the fraction of Twitter users over here on the y-axis, and on the x-axis you have the number of followers per Twitter user. And what you can see is that most people have essentially no followers, right? So there's and you can see it drops off very rapidly. There are very few people that have more than 100 followers out there. You know, so you kind of talk about the way that Twitter works. People kind of think about it. Oh, there's, you know, these people, thousands of followers, and obviously there are some people that have the thousands of followers. But for the most part, what's happening is, you know, 90% or so of people out there have no followers, and that's the distribution of it. It kind of follows this exponential decay. And there's something similar to that that's occurring with online simulations. So this is some data that I took from a sim for a month from now 3 or 4 months ago, and I thought I'd use this slide for today. And what it's showing is some of the sims that we're running over the course of a month that I just kind of pulled out at random. So this isn't everything, but this is sort of a random sampling of about, in the end I think I used about 50 sims for this, and I'm only showing you the first set of them. But what you can see here is that these sims too are following a power curve. You can see that there's a small number of simulations that get the vast majority of traffic that are the most popular, and then there's a small number of simulations that kind of follow that long tail, sort of that long tail effect. And really what I want to talk about today is what are those things that will make the sim that you build kind of fall into this first category here. How can you put your sim up into that 1% or less of simulations that get lots and lots of traffic and that get used frequently, if that's one of your goals. And even if it isn't one of your goals, even if you're producing a simulation that is for, say, 12 people or 4 people or something like that, these same principles apply, just because what you want is for people to enjoy the experience and to learn from your simulation, and those are really the keys that we're getting to. In fact, the fundamental things that we're trying to do in order to get widely used simulations is to make them understandable, convenient, and enjoyable to use. So what we're going to be covering in this next section here is basically dividing it into thirds and talking about what are things that make sims easily understandable, what are things that make sims convenient to access, and what makes them enjoyable to use. So we've kind of, through the last 5 weeks, we've talked about tools that you can use for that, but we haven't really gotten into how do you design these things in order to accomplish those things. So we're going to proceed from here into that. Starting off with easily understandable. By now, probably you realize that that this is not a simulation, right? So this is an example of a model. I believe this is the mobile phone sim model, the equation list that we have here. So one of the things we're distinguishing is that the model is a separate piece from the user interface. The user interface and the model together create a simulation, and this is just the model. And likewise, by the way, this is not a simulation. This is another view of the model. It's another way of representing it. But a model is this combination, or excuse me, a simulation is the combination of a model and a user interface. So here we see the user interface, the model running underneath it, and it's creating this user experience that makes it accessible for people. And so, in the end, it's the user interface that your customers, your clients, your students, your colleagues, all these people that are going to actually, that's their view into the work that you've done. That's their view into your model or into into the interaction that is the only thing that they're going to see in the end. But fortunately, in terms of designing this, it seems a little bit daunting at first, at least to me. But the good news is that users have, there's some rules that we can follow in order to make this work well. Users have expectations about how these applications work, and there's a category of internet applications called rich internet applications that I believe all simulations fall into because they're so highly interactive, and there's sort of a wide variety of definitions of what makes up a rich internet application. But I think the key one is that you're doing something on a web page, you're interacting with it, and results are changing. And obviously there's a lot of things that do that. And I think actually a really good example of that is Amazon. And in that there's lots of people anyway interact with Amazon, and they've spent millions and millions of dollars on perfecting their user interface and doing lots of testing and things to make things work really to make it familiar and easy to use. And this next section, what I'd like to talk about is how we can benefit from using designs that other people have already put together. That there's a set of rules that are out there that apply to web-based tools outside of simulations, that if you apply to simulations, it's going to make it really easy for people to understand how your simulation works. And so the goal is, in general, not to kind of try to invent new ways of interacting with people, but instead to use familiar ways, maybe in interesting ways. It doesn't mean it has to be boring, but use familiar tools so that people immediately know what they're supposed to do when they're inside of a simulation. When you don't do those things, you're going to have the potential of frustrating users. So what this is a picture of actually is a door that now, a few years ago, I took this picture actually probably 4 or 5 years ago, because we used to go to this Indian restaurant that was near the office, and you can see sort of the problem here in terms of design issues. We have this thing on the front here which clearly says push American Express, but what we see here is this affordance, what's called an affordance here, of a handle that looks like you can pull it. And the problem was every day we'd go to this, or every time we'd go to this, probably once a week or once every 2 weeks, we'd go to this thing, and you pull it and you say, it's not open, what's wrong? It's like, well, you have to push. Well, the problem is that the design pattern here, this affordance that indicates that you can open the door by pulling, is wrong. It needs to be a plate or something like that. And below here, what you can see is this little area that's painted in red. That was actually kicked in. It says something about the quality of the restaurant we're going to, but it also says something about the frustration potentially that some people faced when going into this restaurant. We don't, like I said, we don't go there anymore. So getting into what are those things, those common tools that you can use for creating basic web-based simulations. One way of categorizing them that I think sort of sums up some of the material, especially that Billy has been going through with you over the last 3 weeks or so, is things that produce quantitative output, things that produce qualitative output, user decisions, and actions and navigation. So I just want to cover those in general, and again, maybe remind you of some of the things that Billy has discussed with you earlier. So one of the easiest ones, of course, is quantitative output. And here you see graphs as an example of quantitative output. That's something you can produce easily within Simulate. Billy also showed you how tables work. Here's a table below here that shows some results. And these look fairly simple. You say, oh, well, these are obvious things to do. It turns out, actually, doing a high-quality graph that's easily understandable and a high-quality table that's understandable can be sort of challenging. I mean, there's plenty of, it's not that difficult in some respects, but there's plenty of places to mess up and make charts and graphs and tables confusing. And one of the things I thought would be useful in this final class here is to point you to some resources where you can get some additional material on how to build these things out. In particular, I like this bottom thing here. There's a fellow named Stephen Few. I think he's actually in Berkeley now. He lives in the Berkeley area, and he's written about data visualization in a very fundamental level. He has this thick book. It's about 1.5 inches thick, and it's just about building tables and graphs. It's just about this stuff. That's it. And it's amazing how much detail he gets into all the things that you can do wrong and what you can do correctly in both circumstances. And I just think it's a fantastic book. I refer to it frequently and often share it with people here in the office. A number of people here in our office have read it and at least have used chapters from it in order to design things. And often when new people are starting, we have people look at some of the material on there. But that's a really good resource. So that's something later on you'll be able to access, as we have in the past, access both the this PowerPoint presentation and the other stuff to get back to that. But you can find that on Amazon or elsewhere. In addition, there are some chart tools that are available. Fusion Charts is a tool that we've used historically for producing Flash-based charts when you're doing the HTML style simulations through the API that Billy showed in week 4. Now, you don't need to use those if you're using the Sim UI Builder, so I'm including another chart tool, is this Forio Simulate UI Builder that Billy's more or less demonstrated over the last 3 weeks. And what we've tried to do with that tool is incorporate best practices in terms of things like what Stephen Few talks about and elsewhere into the tool. So one way to sort of accelerate this a bit is to start anyway with using the default values and then start tweaking them to make it match up with your own style and things like that. Another sort of interesting tool that's useful here is this chart selector, just thinking about different styles of charts and when to use them and things like that. Oops, I'm not going to have that right now, but that chart selector actually is a useful way of kind of thinking about how to build these things out too. Moving on from quantitative input to qualitative input, there's a lot of things in simulations that need to be qualitative, that go beyond just showing value numbers and graphs and things like that. And we want to sometimes show mood or frustration or other things. There's leadership simulations that get built on this platform. There's change management simulations. There's all kinds of topics that get covered that aren't about, say, business analytics or about public policy or things like that. So, there's a number of things you can do, and by using things like text, images, and video, you can incorporate some of those. So to give you a little bit of a flavor for that, here's an example from a simulation that we built that is around project management. And there's some indications in here of some things that, obviously there's some quantitative things in here, but this page in particular has some qualitative things on it as well. And I'd just like to ask Martin, who's sitting here beside me today. Martin, do you see anything that would be qualitative from the simulation? So Martin says that graphic jumps out at him. Yes, you see the guy there that is holding his forehead. And you see anything else that stands out as far as a qualitative result? The quote above it, exactly. Yeah, that's exactly right. And so, there's a few things on here, 4 major categories of things that provide qualitative results here. You can do a picture like this, as Billy illustrated in an early course. You could do video. You can also see here even soft variables like team morale and team stress and productivity can be modeled in kind of qualitative terms, but showing it's going up or down. And we're not saying what the actual numbers are. You can see this team stress is getting worse or going up over time. And likewise, these indicator lights are sometimes a useful way of illustrating that. So there's a number of ways of illustrating through text, video, and basic graphics qualitative values in a simulations. And sometimes it's actually useful to show even quantitative results through qualitative means, because it makes that point a little bit clearer. It makes it come through a bit stronger. So here, for example, we see diffusion dynamics, and this is a common problem that gets modeled with system dynamics models and other forms of models, where you show adoption of, say, like the iPad over this past year and into the, say, 3 or 5 years into the future. So you could say, here's the number of customers ramping up over time, and here's the diminished potential customers. And that does illustrate the point. You can sort of get the sense what's going on. But sometimes if you want to make that point more viscerally, you can do so by using other forms, other kind of qualitative forms. And I think an example of this is a video. And actually, I think this is a video that that explains diffusion qualitatively. Now, I'm going to try something here that I've never tried before, and I'm not sure it's going to work, but we'll give it a shot. And that is running a YouTube video through GoToMeeting. So we've got like layers and layers of technology here, and I'm not sure that it'll function, but we'll give it a shot. So here's my YouTube video of the Sasquatch Music Festival attempting to illustrate how diffusion works. And because I don't know if this is going to work, I'm going to roll this. Well, I'm going to start this off a little bit. And I don't know if you all can hear any music. Probably you can't. I can hear some music here. It's actually pretty entertaining music. You see, I have this one guy dancing here in the background. He's dancing by himself at this music festival. I think it actually took place in Oregon or something like that. Washington State. Okay, that's where Sasquatch is. Okay, so Matt, who's sitting across from me, knows this in Washington. And so now he has one guy join him, so the count is going up by a little bit here. And it's going on. Still two guys kind of dancing around. Can you guys see this okay? Okay, good. I'm glad it's working. All right, so they're dancing around on their own there, acting crazy at the festival. It's summertime. All right, finally a third person. It's, we're a third of the way into the video at this point, and we only have 3 guys now dancing out there on their own. Slow ramp up here. They look like they're having fun though. Oh, there's a couple more people. That's good. It's starting to build up. Oh, there's 2 more. Here we go. There's some more. In my headset right now, I'm hearing lots of screaming, as well as the music. Group's growing now. What do we got? 15 people there, 10, 15, something like that. Here comes some more. Other people starting to see it. All right. There's some screaming going on in my headset. So now we're 2/3 of the way through the video at this point. All right. All right. I think you're getting the idea, so I'm going to stop it there. Well, actually, you know what? I'll take it to the end. Roll it up. There's kind of the end of it with now many people. I'm not going to try to count that. A lot of people showing up. And I think that it sort of makes that point. I think it's interesting to kind of divide that out that way, kind of think about how, like, there's this slow ramp up. You think this guy's, he's sitting on his own, looks kind of painful, and then kind of starts to get some friends, and then, eventually when it gets to the point where you get this critical mass, you have this inflection point, and it starts to grow. And, I think that illustrates the same. Here you can see the same thing, right? With a very low number of people initially. It's pretty flat. Eventually you reach an inflection point, it grows very rapidly, and then it starts to level out. You get that basic S-curve. But it's a different experience seeing something like that, right? It's the difference between the qualitative and quantitative point. So I guess I've made my point with that. I'm going to move on now. But anyway, another thing that we need to look at here are, how do people interact with this? How do people interact with your simulation? And Billy illustrated a few techniques. There's radio buttons, sliders, text boxes, and check boxes. A lot of people think these are boring. But the fact is, people know how to use them, and a lot of simulations that are that we're building, that Forio builds, and that people that our customers build using our platform, are creating an experience where people are only going to interact with it one time in their lives for an hour, or even 3 hours, or sometimes even only 10 minutes, and to have them, you have to educate them about an unfamiliar user interface at the beginning. Is not a good use of that time. We want them to be able to jump in immediately understand what they're supposed to do, and the content can carry the excitement of it. It's not the coming up with clever or unfamiliar ways of, clever ways can be fine, but clever unfamiliar ways of doing navigation and or sort of decisions and things like that can be problematic. So we often like to use these sort of what seem like very standard ways of interacting with websites, because it allows people to ramp up very quickly in terms of being able to build things. Lastly, I want to cover basic things that we have in sort of the action navigations categories: buttons, links, tab navigation, creating hit areas, even drop-down lists and things like that. Again, that's going to help make these simulations understandable. And Just as an example of that, here's a basic tab navigation from a simulation that we built around innovation. Well, you can see up here that there's these sort of tabs up here and then a level below that. I'm going to show you later on today how we went through some iterative design to come up with what essentially seems really obvious probably to you. You look at this and say, yeah, big deal, there's tabs and things underneath, I see that every day. But it turns out that a lot of times when you kind of play around with these things, it takes some iterations to get to what seems fairly obvious in retrospect. There's other approaches to this too. You don't always have to do it that way. You know, here's this simulation that was built in Forio Simulate using the UI designer that didn't use tabs, but uses sort of still a fairly familiar interface. You can see here that you're on the dashboard, and there's other reports that you can get to by linking to these financials and decisions and things. And there they are up there. Okay, I'm going to move on. So that's sort of the beginnings of that. We want to move on to convenient to access and get into some things too about getting, again, the goal is to get lots of people to use your simulation. And one of the problems that we're facing right now is that web browsing tools are becoming increasingly diverse. In particular, what we've seen, especially over the last couple months here, is that the iPad has come up, so I put a little iPad down here at the bottom. But we also have people who have gigantic displays, so there's a wide range of things that are going on. What we've seen is that about 96% of all displays currently are at 1024 by 768 or higher. And so our objective in building simulations is to start with that as kind of the lowest common denominator. So that way we're going to capture 96% of the market. If we were willing to go down to, say, 80% or so, we could go up to a 280 as a horizontal space, and that would give us more. But losing 20% of possible users is too high. 4% is sort of painful still, right? But if we design for 1024 by 768, we're going to capture 90% of the people. And so when you're designing your web sim, that's something to keep in mind, is to make sure that the sim that you're developing fits within 1024 by 768. You might have other constraints as well. If you're building one that's, say, going to fit inside of a blog or inside of other content, you know, it obviously needs to be designed against that. But and by the way, what we've done inside of the UI designer is put a default in there for that setting that's going to help you with that. So I'm going to show you that. Here's a slide on how that works. I wanted to include this so that when you went back to the slides later, you could see that. But I just thought I would illustrate that here. So here is the UI designer. And Billy showed this briefly at one point. I sat in on all Billy's sessions here, but I just want to show you how this works. So let's say I was clicking on something like View Model here. I can see the button settings over here. But if I click off and click on this blank area, which is the document, I get something called Document Settings up here, right? And so if I click over to the tab Document Settings, what that allows me to do is set up the simulation width and the simulation height. And what we've set here for you is a very conservative number that will make sure that it fits in 1024 by 768. We leave a little bit of room on the sides, about 44 pixels, 22 on each side, and some up and down height too. It's very hard to predict what 768 means in terms of height because, you know, my browser is fairly thin right here, but some people have lots of toolbars and other things open, and that consumes vertical space, so we went with a fairly conservative number here too. So you can play with that a little bit if you want to change it. But my point is, by clicking into the document and clicking Document Set, you're going to be able to change those numbers. And in general, you want to have it set to something that's going to allow 1024 by 768. Okay. Simulations, web simulations need to operate on a variety of operating systems and browsers. And so we're seeing here, you know, fairly current data. By fairly current, I mean within the last 6 months, where we are in terms of different browser types that get used. We're seeing that, you know, Firefox is dominating, although Chrome is growing very rapidly. I was checking this morning again, and I saw in the latest information that Chrome is at 22% market share for general web use, which is surprising to me. And then, you know, we're seeing that it's still largely dominated by Windows machines. Mac is growing somewhat, but not as rapidly as, say, Chrome is growing in the browser side of things, and that can make a difference as well. There's also a point here to make about using other tools. Like sometimes people say, well, we want to use the simulation along with other kinds of tools that you need to access. And for example, a common one is Excel. Surprisingly to me, at least, probably because I'm a guy who works in with businesses a lot, is that Excel is only installed on 75% of all computers. So now that may vary depending on what your audience is. You may find that your audience has 100%, but if you're producing or designing something for a general audience, what you're going to find is that that a small that you're going to lose. You potentially could lose 25% of your audience if you require Excel to be able to use it. You can still make Excel something as an option for people that want to use it. That's something that we've done in other simulations. But in general, I think building a simulation so it's standalone and doesn't require outside tools to work is important. And I think this chart sort of illustrates the basic problem, right? Which is as you require more and more, or you place more and more requirements on the user, you lose more and more users, and each one kind of nibbles away at the total, right? So here we have 100% of all users at the beginning, but if we say our simulation requires Windows, it's only going to work on, say, Internet Explorer, then we're going to eliminate 20% or 30% of our users potentially, depending on your user group. If we say Windows users that have Firefox, so I'm contradicting myself, but then we're going to reduce it further here, and then we say with Excel we're going to reduce it further. So the point is it kind of goes down over time as you add up these sort of different facets to usage in the simulation. I thought it would be interesting to show you one of the things that the tools that we use a lot is something called Google Analytics. We use this for our own sims and also our own website. And here, just to give you the latest information, we're going right up till yesterday in terms of results here. This is the last months of data for Forio Simulate, just illustrating what our current usage is on this. And what you can see here is that currently about 35% of users are Internet Explorer. That's actually higher than Internet or the Internet worldwide. So for some reason, our pool is a little bit different than worldwide Internet on this. Firefox is pretty high, and you can see here Chrome is just cranking right now. We've got 20% on Chrome, which is actually just slightly lower than the whole Internet. I think Chrome Internet-wide is 22%. And then we have about 10.5% for Safari, and so that makes up nearly everything for browsers. Quick data here on the use of Simulate users who are using what operating system they're using. 80% are using Windows, 17% are using Mac, and that's 97% of all users. So we have a small number of people who use Linux. That might be skewed because we have one person in our office who uses a Linux box. He may be influencing that result. But I mean, actually, that's not true. There's lots of people that are using Linux as a tool, and it's a fine operating system to use for this, so it will work out great. Here we're seeing sort of interaction among these things. But I think another one that's sort of interesting here is screen resolution. So what you can see is, what this illustrates to me, by the way, is this diversification of screen resolution. So you can see here, when I looked at this 3 years ago, there was just 10 or 8 or something like that, different resolutions, and now we've got 50. Actually, we have 140 total. So it's just really grown a lot. But if you look at this list and you look at 1024 for the left and 768 for the right, what you can see is that at least for the first 17, you see nothing below 1024. And for the first 17 too, you see nothing below 768. Now at 17 we get, or 18 rather, we get 380 by 480. Now that is a phone. What someone's doing there is using a phone to access it, but we're only talking about 0.5% of all users. So, we're up to 99, close to, well, I don't actually know what that total is, but my guess is that we're above 95% or more for the first 17 users. Obviously, I could add it up, but so that has an effect. Currently, in terms of Flash use, we're in pretty good shape still. So we have only 5% of users who aren't using Flash. So 95% have Flash accessibility, which is pretty good. And most of them are using Flash 10. We're up, of those that use Flash, nearly everybody has Flash 10 or above installed, which is sort of nice. Adobe, who owns Flash, does a good job of kind of updating that over time. Lastly, to look at client-side Java. Now, I don't think we've talked about this in any of our talks so far, but Forio Simulate is written on Java, but there's confusion about what Java is. There's server-side Java, meaning it's running on the server computers. is a very popular, robust language that is running huge applications, industrial strength applications for all kinds of companies. IBM and Oracle and Microsoft all produce Java web server applications, and and we host, and our sims are hosted within that in those kinds of tools on the server side. But there's also client-side Java, and client-side Java turns out not to be a good platform in general for running these things, at least in my opinion. And the reason for that is right here. So the problem is, if you use client-side Java, you're going to lose at least 12% of the population, because, or meaning that you're only going to have about 88% of your customers available because 12% don't have it installed. But even among those 8% or 88%, there's like these different versions and things like that, and you end up with problems in terms of compatibility and things. So that sort of illustrates that point a little bit. Moving on, one of the other things that you need to do in terms of accessibility is make your simulation interruptible. And Billy illustrated some ways to do that with the run manager, meaning that you can go back and load old runs and things like that. But there's really two ways to go about making your sim interruptible. People, when they're testing sims, often get confused on this point, because when you're testing it, you're in usually a weird environment. When we do tests, we'll run them in a conference room. We'll invite people in. We'll pay them like $50 to help us test for an hour or two, and they'll be sitting there and we'll be watching them. And of course, they're not going to get up and do something else in the middle of it. And so this is an easy point to forget about when you're testing simulations. But in the real world, what happens is people get a phone call. They get called, someone else asks them to come over and look at something, or if they're at home, there's even other pages. There's a lot of reasons why they can get interrupted in the simulation, and so you need to design the simulations in a way that, especially if it takes more than, say, 15 minutes to play, that they can get back to where they were. And by the way, this is a nice safety mechanism as well if something crashes, like the internet can go down somewhere along the way. Your computer can crash. There's all kinds of things that can happen that can interrupt a game, which would be really frustrating if you've spent even more than a few minutes playing something and making decisions. Like, I want my old decisions back. I don't want to have to redo everything from scratch. And so the two easy ways of going about that is by either making your game really short, making it 5 minutes, your simulation really a short experience, then you don't need to worry about it, or providing ways, as Billy illustrated, through using resume run and things like that, and providing a page where there's a run archive available for users. The last bit here that I wanted to cover, well, actually there's one other thing after this, regarding accessibility, is requiring things from users. Now, Matt, one of our salespeople here, would love it, I believe, if on every simulation we requested lots of information from our users to sort of gather information on them. But we don't. And in fact, one of the things that we've tried to do, even in the design of Simulate, is make it so that you can do a lot with Simulate without ever signing up for it. You can play sims. We only ask people to create a login, essentially, at that point when there's no other, we absolutely need it. So you can sort of walk through it. And the reason for that is partly because of an experiment that we did a few years ago, where we had a simulation that was fairly popular. It was receiving a few thousand uses per month, and it was one of the that we were using ourselves, that we sort of owned ourselves. And so we did this experiment where we asked, and this is what's great about the web too, is that you can conduct really simple A/B style experiments, because you can easily randomize things on the web for what pages you're serving out to users. And so half the users that went to this simulation, we asked them for just an email address, and that's all we asked them for. Just enter your email address. So you could even enter a fake one, and that was the only piece of information we requested. And the other half could jump into running the simulation immediately. And then what we looked at was how many people completed the simulation. What was the difference between the two? And I think it's a little bit ambiguous, because you might think, well, if people who enter their email address might be more reluctant to do so, but once they've done it, they might more likely complete the simulation. They have sort of higher commitment. So in advance of this, I wasn't sure how it came out. But actually what happened was, when you require people to enter an email address, you lose half your users. So that's a huge drop-off. And We've had discussions with clients and customers at times around this issue because sometimes people want us to have elaborate web forms in advance of getting to a simulation, but there are other means of going about that to solve that problem. And sometimes it's okay. I mean, in some cases it doesn't matter. It's worth that drop-off, but it's just good to be aware that you're going to get one. There's been a lot of discussion over the last year for people who are into web design stuff, and I'm sure some of you are into that category, that HTML5 is this revision, and it might eliminate the need for Flex or Flash. And I believe, like many people who are interested in sort of following web trends, is that HTML5 is the future of the web, that eventually, and by eventually I mean 4 or 5 years from now, we're going to be in a world where HTML5 is kind of dominating in terms of rich internet applications on the web. But the problem is that we're not there today. So it's 2011 now, and we're looking at a world where about 1/3 of all browsers don't have HTML5 support, and it won't be until later this year that Internet Explorer even comes out with a fairly robust set of HTML5 support in Internet Explorer 9. And so there's a ramp-up period that's going to occur with that. And my point is, I think HTML5 is the future. I don't think that it's a good decision this year or next year even to build simulations that are exclusively for HTML5. The goal for us is to design simulations that are both HTML5 and HTML4, meaning current HTML style, compatible, and that's the way that we've set up Simulate. And by the way, for those of you who use our platform, who use the UI designer and other things, we're kind of helping you with that, right? So we have in our own our development schedule over the next couple of years to provide HTML5 support with these tools, so that as this trend sort of continues, we're going to be able to, you're going to get that as part of our own development with the platform over time. So that's a way that kind of leverage our own work into your work with that. But if you are designing your own HTML simulation, my advice is to begin to support now HTML5 in terms of interactions for the browser, but also support older versions of HTML largely through Flex and Flash. I think that's the way to go for the next couple of years or 3 years or so. So what we recommend, just to kind of sum this all up, is 1024 by 768 for the screen resolution, HTML with JavaScript and/or Flex Flash, testing on both Windows and Mac, and testing on IE 7, 8, and 9, Firefox, Chrome, and Safari. That's a lot for browsers. We actually just ended up adding 9 here recently because 9 is in beta right now, and we've actually run into a few people, a very small number, like 1% or so, that are hitting 9, but since that's going to grow over time, we decided to add it to the mix already. What we discourage right now is client-side Java, a video that doesn't use Flex or Flash, and the reason for that is that it's really hard to get video to work across browser-specific systems that rely on HTML5 exclusively for developing things, and things that rely on desktop applications. Okay, moving on to enjoyable to use. What we're seeing is that games and simulations are converging. So this is a graph of words that appear in books on games and simulation. And what you can see is that the games and simulation. Actually, I have this as a slide here too. Games and simulations are ramping up. You see, in the 1950s, there's almost no references to simulations, and it's been growing over time. It's maybe leveled off. It's pretty good. Whereas games has been steadily growing over the years here. Now, what I like to do before is I would put in the word model here to illustrate that. But there's a problem with that when I put model in. Let's see if I can get this thing to come back. There it goes. You can see model kind of throws everything, is a lot higher than everything else. And I was confused by this at first, and then I realized, of course, there's other kinds of models than sets of equations that may be the reason for that growing so much. So this result actually just works better when you just put these first two. It's more meaningful, I think. All right. So what I want to move on to now is talking about ways to make your simulation enjoyable to use. And what I want to talk about too is, sometimes I think this seems daunting to people because when people think about making things fun. When they think about games, the way I was just illustrating in this last slide, they're thinking about console games. They think about the Wii, PlayStation, Xbox, other kinds of games that are out there. And here's an example of one where they have these this cool 3D world where you interact as where you're moving through this stuff, and it's very elaborate. And there's people who have done designs around this kind of stuff too, and it does seem a direction that you might be able to go for a web-based simulation, but there's a problem with that, and the problem is one of budget. So a typical console game that runs on the Wii or PlayStation or Xbox costs about $40 million. It's like making a movie. A typical simulation game budget is less than $40 million, at least in my experience, considerably less. So the line I put on here was $100,000, which is still a healthy budget, in my opinion, for a web simulation. And even with that, it's just like one pixel across for illustrating that difference there between 40 million and so on. But that said, what that points to, in my opinion, is that you don't need to. What you shouldn't do is design these you shouldn't look at that as your target in terms of design, because there's lots of great designs out there that are of games that are really, really nicely done that are not console-style games. Casual gaming is really the target, I think. Here's a really nice one that it's a Boggle game that's done online. It's very simple. You can see all these elements on here are things that we're already all familiar with from the stuff we've gone through over the last 5 weeks, and it's very entertaining. It's a very entertaining game. And instead of thinking about sort of getting interested in all the technology, fancy technology that go into creating, say, a 3D world or things like that, think about what is it that's going to make people excited and make a simulation fun to play. And not all of them, but some of those are things like intermittent rewards, leveling up, and player communication. So just to give you an illustration of intermittent rewards, I think Monopoly is a good example of that, right? So here's what looks like a very wholesome scene, 3 guys in their college dorm, presumably. It looks like a cinder block dormitory. This is a typical Midwest University dorm in the U.S. And it looks like they've taken one of their beds and they've used it as a table for a Monopoly game, and they're all playing there. And if many people, so I think there's some people on the call today who aren't from the U.S., but most people probably have heard of Monopoly, and it's obviously a popular game in the United States, and it's a very simple game, really, because you roll the dice, and typically what you do when you play it is you roll the dice and you have a strategy in mind when you begin it, right? You sort of say, okay, I'm going to move whatever squares the dice indicate to me, and once I get there, then what I'm going to do is either buy the property or not. I'm going to buy certain kinds of properties, but you sort of have the strategy in mind at the beginning. And early, like this is an example from a game from the late 80s, early 90s, that is a Monopoly copy that ran online. And early on with game design, people are thinking, well, I'll take classic games that were built for board games and things like that and turn them into online games. And it turns out that's not a good strategy a lot of times, because making a game more efficient by running it online actually reduces the fun of it. So if you think about the Monopoly game, if you have the computer roll the dice for you and move the pieces and get the cards and sort of do everything, then all the sort of interaction, the intermittent rewards aren't recurring inside the game. In fact, what you could do if you take that to its logical extreme is say, well, just tell me what your strategy is, press go, and I'll tell you if you won or lost. That would be the whole game right there. And obviously that wouldn't be very much fun. So it's the intermittent rewards that contribute to that, and building in some sort of ways of slowing things down, making it actually a little bit less efficient in order to make it fun to play. So what we want to add into the simulation is opportunities for people to experiment, people to fail in the games, obviously, and also for repeated play. Allow people to interact with each other multiple times, and even in things that are more serious, like this is an example of a sim that we built for the Centers for Disease Control, and it was built to look at public policy issues over 25 years, but it had these elements in it too to make it more entertaining and something that people would interact with. Another thing that you see in a lot of games is leveling up, and leveling up means starting easy and gradually adding complexity over time. This is one of these things that I don't think is done enough in simulations in games, in that usually you start with a full complexity at the beginning, and I think that there's a lot of benefit to thinking about ways that incorporate this into your simulation design. We've done a little bit of it in some games where we've said, well, in early versions, what you need to do is the computer provides a sales estimate for you. In this one, this is an innovation sim. But in later rounds, as you get expertise in it, then you need to start making that estimate yourself. That's a very simple example. But my point is that if you can incorporate ways to let people start simply and then grow from there, that will make the game more interesting and keep people engaged because they can learn as they proceed, not have to learn everything up front and sort of front load the effort in understanding how the simulation works. So some of you probably have heard of the beer game before. It's a game that was designed at MIT in the 60s. It was originally called the refrigerator game. And in my opinion, as far as a game design, it's terrible. Because it's an example of a game that's fully front-loaded. It's super complicated. It takes 30 minutes or more to provide the directions. We've run it. We have 8 boards here in the office that we run periodically with groups when they request it. And there's all these forms that you have to fill out. We have to hand calculators to everybody to play it because you have to add up numbers and things like that. People make huge mistakes all the time when they play it and things like that. And also, by the way, you can never win this game. There's no way to win the game. So it has all these what would generally be considered huge failures in the design in the game. And yet, it is extremely popular. And when people play it, they love it, right? So why is it? What is it about this game that makes it fun? Well, my opinion is that it's the group interaction. It's the fact that you have 8 people sitting around a table, and they're interacting with each other and communicating with each other, and that's what's making the game enjoyable to play. So team-based simulations, like Billy illustrated last week, are a good way to do that. But in addition to team-based simulations, doing even simple things like leaderboards can help encourage competition in other kinds of interaction and things like that. So so those are some of the key things that I wanted to illustrate with that. Let's see. I want to switch gears a little bit here and get into a little bit on project management, just quickly here, and talk about the style of project management that we use in projects. And this will lead up to my initial question: is the single most important thing you can do to create a high-quality simulation? I know we're at the last 10 minutes or so of our talk today. What I wanted to do is illustrate that that simulation development can often be very much like a software development project. And if I thought it would be interesting to see here, where do I have it? Here we go. Sorry about that. This is our generic project plan that Forio uses for projects, and we go through this phase of assessment, design, development, alpha, beta testing, and often field testing in here, and then release. This is sort of heavy, I think, but it illustrates some of the points that I wanted to bring up regarding the design of these simulations. That you should, I believe, treating this like a software development project is a good way to proceed. And there's lots of lessons from software development that apply really well to simulations. The things we do in terms of doing wireframes and visual mock-ups first for the user interface before proceeding to actually building the model. There's things around doing the development in an iterative loop multiple times. So we see here 2 to 4 times for this loop. And critically here, doing lots of QA. In fact, we have a couple of QA people that are from our office that are watching this presentation today. So, that really helps us guys to have that QA, obviously, as you know. And alpha, beta, and field testing is obviously critical as well for proceeding through that. So that is the design cycle that we recommend for building these things out, doing lots of iterations, and not not kind of going through and being underwater until the very end and then showing to your colleagues or your clients or your students the final simulation until the very end, but doing it in an iterative approach over time. A lot of people ask us, how do you go about the initial design? How do you go from concept to building a model? So, you know, the interface stuff is kind of familiar sometimes, but the concept of going from concept to building a model can be challenging. And what we use is this facilitation technique. It's a kind of a brainstorming technique that goes through divergent and convergent things. We just basically ask subject matter experts for things. We're using hexagons in this case, or paper hexagons on a wall, but I don't think that matters. I think that what's critical is that you go through some kind of brainstorming technique. It could be even as simple as a flip chart and writing things down, but you could use Post-it notes too, or you can use whatever technique that you personally like to use for brainstorming. But I think this is really important because what this avoids is the problem of the modeler building things that are easy to model versus important from a pedagogical or from a subject matter perspective, right? What you want is the subject matter experts to drive the design of the model and not the modeler to drive the design. And this is our one approach to it. There's dozens of approaches, but you know, this one is working for us. So here's an example of one of the hexagons here where it kind of gets into showing how some things that a group of, I think there were 7 people in this room that were going through this that kind of listed out some issues that were categorized. And what we do is we put in issues here, and then we put variable names down separate from issues so that we can use those in a diagram that shows how things are linked. So here we have something that's kind of looking a little bit like the Model Explorer. It's a causal diagram or a causal loop diagram. And we can see here that we're kind of linking these things together. We have profit is linked to revenue and total cost and so forth. So we're going back and using those things to link these things together, and then cleaning up that diagram. And this essentially becomes the roadmap that was used for building sims in a project. That same process actually goes on, or an iterative process goes on in UI design. So here's a pricing simulation that we built with Harvard. It's one of the few that I can show in this level of detail, so I use this example a lot. But this is a UI design that we did. It's kind of a throwaway design in the first 3 weeks. So we built an initial version of the model, and then 3 weeks later provided this very simple design. You can see it looks okay, but it's pretty plain. The next version, we went to this design, which was intended to be at least a possible final design for the simulation. But it turned out to be too complicated for a variety of reasons. It had a lot of extraneous detail in it and things in terms of the design. So we ended up going to this design, which actually was close beginnings of what was actually looked like the final design, but this too had a number of problems. What you don't see here is that you can click on Analyze, and if you clicked on it, a little drop-down would occur, and you'd see 8 or so submenus from this, but no one was able to figure that out. I mean, when we told people they could figure it out, but if they were trying it on their own, they couldn't. And so what we ended up going to eventually was this design, which had the tabs and things like that. So here you can see an example, like I said earlier, of how the tab design actually took a few iterations to get to. And I think actually that's the consequence of the fact that even things that seem obvious initially actually need multiple iterations to go through. And now what I want to get to is, what is the most important thing you can do to create a high-quality simulation? Well, in my opinion, the number one thing you can do is frequent testing. And frequent, I think, and what that means for us at least, is that you design tests that are easy to do and inexpensive, both in terms of your own effort, but also in terms of dollars for the organization that you work through. This is an illustration from a book on testing that where we had, or to sort of illustrate the point about doing frequent testing makes a big difference doing one big test. So here's an example of 8 testers with one big test, right? So you bring in 8 testers, and they find a few problems here. They're able to identify them, but the worst problems, because these are the problems that hang them up, they can't find these subtler, smaller problems. Whereas if you do multiple tests in iterative forms, the first test you might find fewer problems than with, say, 3 testers instead of 8. But the nice thing is that you solve those problems before the next test. And then the next test, you can get to the deeper, more subtle problems, more nuanced problems. And the consequence is you're going to have fewer bugs. So the idea is do frequent small iteration testing, and just any kind of testing. Any kind of testing is the number one thing you can do. And by that meaning pull your friends in to take a look at the simulation you're building. To more elaborate things, what we do sometimes is we put ads on Craigslist and pay people $50 to come in for 90 minutes to try out a simulation. Sometimes we've done stuff where we've given Amazon gift certificates to students when we're building sims for schools and things like that. All those things can help. Wrapping up for today, I know I'm getting close to out of time today, is just general principles in terms of design. And one of the things I want to illustrate through all of this is that complexity does not equal sophistication, that you can have a sophisticated, simple simulation. And what's more, simplicity can improve comprehension. I think a good example of that is a comic strip that maybe some of you have seen before called XKCD. It's a kind of a geeky comic strip. And you can see here it's drawn with lines here. He says, for example, this guy says, I used to think correlation implies causation. He says, then I took a statistics class and now I don't. And the woman says, sounds like the class helped. He says, well, maybe. And one more, since I'm wrapping up, is he has this one here about my hobby about extrapolating, and he has number of husbands on the y-axis and time on the x-axis, and he says, well, yesterday you had 0 husbands and today you have 1, and as you can see, by late next month you'll have over 4 dozen husbands. Better get a bulk rate on wedding cake. So, like XKCD, if the content is good, a simple design can be effective, I think. So that wraps up our 6 weeks. Thank you for your time. We actually have a couple of surveys that we'd like you to take. These are optional. We'll see if you have surveys. And then after that, I'm going to stay on the phone for a few minutes just to see if people have some questions. But what I want to do now is just, let's see if can we push out the first survey, Matt? Okay. So we just want to get some, we have 3 surveys today, is that right, Matt? Okay, so we just have three basic polls that we want to get your answers on quickly. And basically this gives us some insights into how this works, and also other things you'd like to see us talk about in the future. If there's some topics that you feel like we haven't filled out in as much detail as we could have, that you'd like to see us get into more detail on in the future, please let us know. And I'm going to leave this particular survey open for another 10 seconds, and we'll move on to the next one because I don't want to spend too much time on this right now. Okay, that's 10 seconds is up. Can we move on to survey 2? And Matt, what's this one on?
What simulations interest you the most?
All right. So what we're interested to is just learning a little bit about the types of simulations and things that might benefit you. We'll share this data with you, by the way, at the end of this. Let's see here. I think we have about 20 people or so today that are on the call with us. We'll just give this a few more seconds. Closing in 5 seconds on this answer. Okay, close. Let's move on to poll 3, and this is the last one. This one is about what area you fall into, I believe. Is that right? Like, are you?
Which other simulations?
Okay. Okay, a workshop. Oh, actually, this is the one my most important one. I wish this was first. I didn't realize it. So this is about, no, that's okay. This is the workshops that you might be interested in the future. This is probably the key one here. So just spend 10 more seconds on this, and we'll wrap up. And I know we're now over time, but what I'd like to do is feel free to drop off if you can't stay on the call with me any longer. But if any of you have any questions at this point, feel free to ask them. We'll just go ahead and close off that survey and wrap things up here. So, Matt, are there any questions for today?
Yeah, will all the recordings be sent together in a single email?
Yeah, we are going to do that. So we've been sending them out kind of piecemeal week by week here. We're going to send out a complete list in a little bit, and we're going to get, what we'll do is we'll first wait for getting this one kind of translated into MP4 format and loaded up. And so that'll take us about 24 hours, and then we should have it up by tomorrow. Any other questions? Someone asked, can you import from Qualitative? And the answer is no. I'm actually not familiar with that package, but if you send me some information on it, we can take a look at it. We're actually in the process of, one of our objectives as a company is to partner with companies that provide useful simulation tools, and we're looking at additional partners for 2011 and 2012. What else, Matt?
The slider bars do not have numeric values on them.
Yeah, the slider bars do not have numeric values on them. Why is that? That's because we're allowing maximum flexibility in the design. So in the slider bars, I'll quickly show you that here. That's if I go in. Can you see my screen, Matt?
Yes.
Okay, so let me go to a page in this sim, I guess. I'll just create a new page, and I'll create a slider bar. Let's see, decision input, slider bar. Here it is, and you can see here it doesn't have any input, but if I start to put labels in down below here, I wonder if I can, oh yeah, if I put in 1, let's say this goes from 0 to 10, I can put these in, and then I can put anything. And what's nice about this is, so you can make them in here, and you can also put the tick marks in and so forth. So there's ways of making this really flexible. What's nice about this is that you can also use words, because sometimes people want to say, I hate it, I love it, great, terrible, or whatever. So that's why we do it that way. But it doesn't automatically put in numerical values at the top. Any other questions, Matt? All right, that's it. Thank you for your time. Sorry I went a few minutes over for today. You know, we enjoyed running this workshop, and I'm sorry that we don't get to have much personal interaction from it, but I really hope that you go out and start to explore Simulate and start building some simulations on your own. As you know, there's free versions and also 4 paid versions of Simulate available. If you have any questions for me personally, feel free to email me. If you have support questions you want to ask, as we've been pointing out, there's a support forum that's available that has lots of high-quality questions and answers on it already, and that you should feel free to post questions to at any time. Thanks, and thank you again for spending the last 6 weeks with us. Bye-bye.